What's up? Welcome to my new math series, Derivatives for Dummies. If you're a dummy like me who has to do extra credit because they made silly mistakes on their comprehension check, then this series is perfect for you. To really understand how to take a derivative flawlessly, then you first have to understand what a derivative really is. Well, what is a derivative? I'm glad you asked. As you can observe on this line, there is no single slope. At every different point, there's a different slope. For example, here, the slope is way different from the slope here. So a derivative is the slope of the line at any given point, or the instantaneous rate of change. Alright, check out this function. This is an epic example of a function that you might want to take the derivative of. So let's do that. Let's take the derivative of it. How are we going to do that, you might ask? The power rule. But wait, what is the power rule? Well, I'm glad you asked. That's the definition of it. Basically, it means that for every term in the function that you're taking the derivative of, you're going to take the power that it's being raised to, multiply that by the coefficient, and then subtract 1 from that power. So, to apply that to this function, here's what we're going to do. Let me write out the function again for you. So, let's use the power rule on here. So the first term, x squared. What are we going to do? Take the 2, multiply it by the coefficient. In this case, the coefficient of the term is 1. So 2 times 1 is just 2. 2x, but wait, we have to subtract 1 from the power. So 2 minus 1, that's going to be 1. Which is basically just going to be 2x. But I'll leave it written there just for the record. Here, next term. This is actually 2x to the power of 1. What are we going to do? Multiply this by 2. Plus 2. Forget about that marker. 1 times 2 is 2x. But wait, we have to subtract 1 from the 1 in the power. So 1 minus 1 is 0. X to the power of 0 is 1. So really, this is 2 times 1, which is just 2. So then that's going to simplify down to 2x plus 2. And that's the derivative. So f prime of x equals 2x plus 2. And that's the power. What's up, guys? Coming back for more calculus? Wow, Isaac Newton and that other guy would be so proud. Well, what if we wanted to take the derivative of something scary like this? Not only does it have a polynomial, but that entire polynomial is being raised to the 5th power. What are we going to do? Wow, I am just freaking out right now. This is insane. But wait. I just remembered something epic that Ms. Sundrani taught me, the chain rule. Basically, the chain rule means that if you have something inside of something, then you're going to take the derivative of the outside, kind of, and then, while it still has the inside in it, and then you're going to take that and multiply it by the derivative of the inside. So, let's try on this one. It's best to just watch how it works. So, the way I'll do it is by using 2 colors. I like to draw a box first that shows what's the inside and what is the outside. So basically here I'll draw my box. So the box clearly shows what's the inside and what's the outside. So now we're gonna do what I said earlier. Take the derivative of the outside with the inside still in it, like this. So basically it's gonna end up like this. Boom, just took the derivative of the outside. But now there's still all that stuff on the inside. Oh yeah, I said that we'd have to multiply it by the derivative of the inside to deal with that. So basically, now we're gonna take the derivative of this. So we're using the power rule right now, so if you haven't seen the power rule video, go back and watch it, then come back here. Bang. Yes, that's correct. That is the derivative of the inside. So now we're gonna multiply that by that. This is our final answer, but I'll write it out more clearly. And that's how you take the derivative using chain rule. I forgot that this is raised to the power of 4 right here. This is the derivative. As it says, it's right here. Now, you may have all been wondering, but wait, what if we wanted to take the derivative of something that has sin and cos in it? Huh? Wait. Sine and cosine. What if we wanted to take the derivative of that? Well, the handy rule is that the derivative of sine equals cosine. That is crazy, right? But wait, I know what you're thinking. But wait, does that mean that the derivative of cosine is sine? No! It doesn't mean that. The derivative of cosine, wait for it, is negative sine. Now I know this is crazy, but you're just gonna have to trust me on this one. So how are we gonna apply this? Well, chain rule for one. I'll show you an example right now. We don't even need to erase. We don't. So let's say we're taking the derivative of sine of 4x. Well, how are we going to do this? Really, we're going to apply chain rule as well. So it's going to look like this. Derivative of 4x is 4. Yeah. But wait, can't forget to take the derivative of the outside box. So really, the derivative of sine is cosine, so it's going to be like this. Okay, didn't see you there. Back for some more Calc fun? I'm sure you are. Well, look at this. In my Calc career, I've learned not to be discouraged by things that look complicated. If we want to find the derivative of 1 over x to the power of 4, we're going to have to do some cool things. It's actually not that hard. It's actually just an application of the power rule. Check it out. Let's talk about exponent rules. Suppose you have n to the power of -4. What does that negative tell you? It means that it's going to be fractional. This really equals 1 over n to the power of 4. How can we use that in this? Oh wait, this kind of looks like that. That's crazy. Now wait, just hear me out. What if we take this and turn it into this? Whoa. And so now, the product rule is way easier to apply here. Just take the -4, multiply it by the front coefficient, which is 1. So you get -4x, and then you have to subtract 1 from -4. Simple power rule. But that's not even fully simplified. We can simplify this further by doing this. Exponent rules again. We're going to get -4 times 1 over x to the power of 5. That -4 is really just a -4 over 1, which means we can multiply these two fractions together to get -4 over x to the power of 5. Boom. Kind of cool.